to another episode of Function Junction. My name is Simon Timms.
And I'm Eric Fleming.
And today we're going to take a look at durable functions. We started that in our last video, which we'll probably link down below. And today we're going to talk about how to chain functions together. So take her away, Eric.
All right. So the first one we'll look at is function chaining. So function chaining in the context of durable functions means to execute individual Azure functions in a specific order. And so typically when you do this, you want to first maybe get some data from another Azure function and pass it along to the next Azure function and to the next Azure function, etc. Kind of chaining these together and orchestrating them in a certain way. So today, I put together a little demo. I've created, I'm calling it the release notifier. And the goal is, so when you release the code, you can hit like this endpoint, this URL or something, and it's first going to go get you some data from somewhere. So in this case, pretty simple scenario, we're going to reach out to the GitHub API, get all of our closed issues with a specific tag. So in this case, it'll be a release 1 tag. And then we're going to send some notifications. So we're going to send an email notification. And once the email notification has been sent, then we're going to send a Slack notification. So just a little example to demonstrate stringing these together. And you can probably see where this could be used for another example down the road of maybe you don't want to send a Slack or the email before the Slack notification, and you want to send them both at the same time. You can also do that. So probably do that, maybe in a different demo. To get started, you need a durable function. You need an orchestrator, which you can see here. We have an orchestrator and we have something to start the orchestrator. And so in this case, it's just a simple HTTP request. We're just going to send a simple GET, and it's going to kick off a new instance of the orchestrator. So come in, we do start new async, and we'll be starting a release notification orchestrator, which is the name of the function above, which is the orchestrator. Once we're in here, and now you can pass data in from this like HTTP request. You can take, if I wanted to pass in a query string parameter, which is probably what we would do if maybe we wanted to make a Slack command that we pass in, a specific tag, and we can accept that in as a parameter, and then pass that to the orchestrator, and it's kind of like the initial input for the orchestrator to know, maybe to do something specific with it. So once we kick off this orchestrator, it comes in, and the first thing that it's going to do is it's going to call an Azure function, a regular Azure function, not another durable function. This one's just going to call a regular Azure function. So this orchestrator here, this orchestrator isn't actually doing any of the work. It's really just, keep saying orchestration, but it's really just orchestrating what's happening. So the first thing that we want to do is we want to go get data. So it comes in, we call this call activity async, which will make a little bit more sense when I go to the other function here. But it will call this Azure function, and this will actually kind of like go to sleep, so to say. So it stops work. So once it tells the other Azure function like, hey, we need you to do something, this goes to sleep. And this will kind of make a little bit more sense as we go too. It's because it's not staying alive while this Azure function is processing. So we call this get release data Azure function, and this is just a normal Azure function, but you can see that its input binding is an activity trigger, and this is so any Azure function that gets triggered from the orchestrator has to have an input binding of the activity trigger. That's just how it knows to trigger this specific function, and this is just a normal Azure function. So we come in, we do some stuff. What do we do? We start to call out to GitHub. So we build the client. We've built the client with some base parameters and everything in order to call GitHub, and then we call get string async on the rest of the URL that we want. So in this case, we're calling our repo to get all of the closed issues with a specific release tag, the release tag that we've passed in here for release 1. So we'll be able to see that in GitHub. So once this is finished, once we've gotten the data, we've called out to GitHub, we've built a new release data model. Right now, it's just got a couple of default values and everything. We can expand on this, make it call out to multiple services, GitHub, Pivotal, Trello, whatever we want, get a bunch of data. And once this is done, so we're going to return release here. So our release object that we've been building up, and you can see here back in our orchestrator, we're actually going to take that object and we're going to pass it into the next Azure function, which is going to be the next, the next step, which is sending a release email. So we're going to use the data from this first Azure function, and we're going to just straight on pass it in. So if you wanted to do this with normal Azure functions without an orchestrator, without this durable, the durable function backing, you would have to get this data, and then you'd probably have to put another message onto a service bus queue or something, some other type of transport, and then handle that with another input binding to pull it off of whatever you just put it on. And it's a little bit more cumbersome. This way, it acts kind of like you're calling into another instance of a class. Like, if you weren't doing this with Azure Functions, just calling out to a service and you get the data and you can pass it along. It's kind of the same idea here, except it's all serverless and it's calling multiple Azure functions as we go. So we're going to take this release data, and then we're going to go over to our email notifier. And this is this is another normal Azure function. The only difference really is that the input binding is an activity trigger because it's coming from the orchestrator. And we're still going to use, so this one's using SendGrid. We're still using the normal SendGrid output binding for this. So it's normal. If this was not in the durable context or anything like that at all, this is the way you'd be doing it with an Azure function. So there's really no difference here. So we're passing in this data, and we're building up the new SendGrid message. I'm just sending an email to myself right now, and adding the content. Just some content formatting here, and go ahead and sending that email. So once this is done, it returns back to the orchestrator, and the orchestrator says, okay, we're done here. Now we can move on to the Slack notification, which is again simple, just another normal Azure function. We build up some text to send to a specific API request or to our Slack webhook URL, and we send that data too. It's going to use the same data as the email did. It's just using this release data for multiple of these functions. So once we've sent the Slack notification, then we're done. So now this orchestration, this is going to exit, and it's going to be complete, and it's going to be done. We can kind of see this in action. So the kind of behind the scenes, which we'll see in a second, is for each step along the way, this is putting rows into the storage queues, kind of keeping track of what's been done and what it's been doing, because of the fact that this orchestration function, it is not active all the time. It's not live all the time. It only wakes up when something's completed and it needs to start to do something else. So let's go ahead and run it real quick, and we'll show that.
So I guess one of the important things in my mind here is that those are weights inside of that orchestration. The functions that you're calling there actually execute potentially on a completely different machine, on a different host, on a different side of the planet. It's not the typical wait async model. It's not running in the same process. It's running somewhere else.
Yep, exactly. Okay, so we can see, so this is just the function is spun up. I had to download Skype before this. Let's hit this URL. All right. All right. So we can see, so I've kicked it off. you can see down here, I sent it to my little Slack, our Slack channel for function Junction. I can show you that in a second. But we can see here, starting here, we made the GET request. No, that's not the GET request. This is the GET request. We made the GET request, and then it starts executing. So it's kicking off this new release notifier orchestrator. And then you can see the log message here, begin release notification orchestrator, matches up to here. So we came in, hit the API request, begin the release notification orchestrator, and now it's starting to execute. And you can see it each step of the way. It's come in. Our first step is getting the release data. So executing get release data. We made an HTTP request. We're getting the release data for release tag release 1. And so you can kind of see how it's continuing through the stack here. And then you can see begin. So you see it come into the release or notifier orchestrator again after we've already done, after it's already come in once and after it got the release data for that first function. So it comes in to the release notification orchestrator again because it spun up, and then it sees that it's already finished the get release data part of it. So then now we see the next log message is sending the release notification email. So it's skipped over the release data. It has the release data that it needs in context, passes it through to the next Azure function for the sending a release email, and then so on and so forth. And then it'll repeat that again one more time for the Slack notification. And we can see over here in Slack, we released. In the issues, there were 2 issues, just a test issue and an issue we had just, I was having trouble getting the data from GitHub, but it got the title of the issue and it got the URL and it output it. I also got an email that came through it as well. So one other thing to show is really what it looks like in the Storage Explorer here. So here we can see kind of what happened, at each step of the way. This is why you need the storage tables backing, because this is how it inserts, this is how it keeps track of everything that's going on. So you can kind of see by this name column here, each step of the way. It started, then it schedules the task to get the release data. Then once the task is completed here, orchestration is completed, then it schedules another task for the send release email. Orchestration completes again. Then we start, we come back into the notifier, and then we go back and kind of do the same thing for the send Slack notification. So it kind of shows you this is all the things that had to happen for that one durable function, but it's all taken care of for you behind the scenes. So let's see.
So if you were to go back to that Explorer and scroll over to the right, would there be columns for kind of the data in between?
Yeah. So the result here, this is holding the data. This is the model that we built up in that get release function. So it has all of the data that was built up, and then this result is what's passed through when the context picks back up for the orchestrator.
Right. So I've heard the team refer to this as event sourcing, which I guess it kind of is. It's not event sourcing in the way that I was thinking of it, but the idea here is that every time you execute it, you jot down what it is that you did, so that when you come back in and rehydrate that, you can load the state of the object by just pulling the stuff down from this table, and then it understands like which functions it's completed and which ones it still needs to do.
Yep, exactly. That's why you see it come in to the orchestrator function multiple times for each step of the way. So it comes in and says, "Oh, I've already finished the get release data function. Let me go get the result of that," and then put that. You can use that data in the next step, and then it continues to keep track. So that's pretty cool. So yeah, I think is there anything else you think
I don't think so.
Should cover?
No, I think it's good. This is a good first start to people learning how to use durable functions. So this is maybe the simplest pattern that you could do with it, and we'll explore some more interesting patterns as we continue through this.
Absolutely. Well, thank you everyone for joining us for another episode of Function Junction.
We'll see you next time.